Today we are studying ethanoic acids. You know that vinegar is an aqueous solution of acetic acid. This solution is vinegar is an aqueous solution of acetic acid. This solution is widely used in our kitchen as preservative and taste maker. The content of this solution is acetic acid in general, and it is a 5% to 8% aqueous solution. The IUPAC name of acetic acid is ethanoic acid. This is a type of carboxylic acid and it is a weak acid. The formula of carboxylic group is C dash C O then OH. This is the carboxylic group. The chemical formula of ethanoic acid is as follows: C dash C dash OH, then double bond with double bond, that is a O. This is the form of carboxylic, and this is the CH3. CH, then one bond H, and other bond H. This is the formula of ethanoic acid, or we can say H CH3 C double O H. Now let us see the preparation. The ethanoic acid can be prepared by oxidizing ethanol in presence of alkaline solution of potassium permanganate to get oxygen for oxidation purpose. The formula of preparation is as shown in the figure. C2H5 OH CH3 double OH plus H2O alkaline KMNO4 plus heat. This is the ethanoic acid. Ethanoic acid. And this is ethyl alcohol. Next, the physical properties. Physical properties of ethanoic acid. It is a colorless liquid. It has got a very pungent smell. It turns blue litmus to red, and it is an weak acid, not like mineral acid. This is used to prepare vinegar and food preservative and add taste to food. 5 to 8% of this solution. This is a 5 to 8% of acetic acid solution. Now let us see the melting point. The melting point generally comes for the solids which is going to be formed liquid, but this is generally in a liquid form. But we should ask for the freezing point. We should think about the freezing point. 70 degrees Celsius or 290 degree Kelvin is its freezing point. Due to its low freezing point, the pure acetic acid due low freezing point, the pure acetic acid freezes at room temperature during winter. This is the freezed acetic acid appears as glacial. Therefore, acetic acid is also named as glacial acetic acid. Now let us discuss about the chemical properties. Reaction with metallic carbonate. Metallic carbonate, let us take sodium carbonate and we see what is the reaction. CH3 COOH plus Na2CO3 Na2CO3. When it will react, it will give the salt CH3 COONA plus H2O plus CO2. Because this reaction is very brisk and fizzing is seen during the reaction because CO2 is getting involved. Now, this reaction is called brisk effervescence because the CO2 is evolving very briskly, and this is the reaction where we can see to test whether it is a acetic acid or not. This is one of the part of the reactions. Let us discuss about the reaction with metal bicarbonate. In the metal, this is also a type of metal bicarbonate. This is also a same type of reaction as happened with the sodium carbonate, like CH3 COOH plus suppose sodium bicarbonate NaHCO3. If it reacts the same thing, CH3, same salt will get it COONA plus CO2 plus H2O plus H2O. This is called sodium acetate. This is ethanoic acid. Right? And this is carbon dioxide gas. Same like brisk effervescence also can be seen in this reaction also. Now let us see the esterification reaction. This is esterification reaction is to form esters by using acetic acid. Esters are generally very sweet smelling chemicals used for preparation of perfumes, food essence like vanilla. The esterification reaction is represented as follows: C2H5OH plus CH3 COOH. It reacts in presence of H2SO4, that is CH3 COOC2H5 plus H2O. This chemical is called esters. This is alcohol, ethyl alcohol or ethanol This is ethanoic acid. Ethanoic acid. This is ethanoic acid. This ester formation, this process is also can be seen. It is a type of a reversible process. Reversible process. Reversible. This can be this from esters we can get it back alcohol as well as ethanoic acid. Now let us see the saponification reaction. Saponification reaction is one of the most important reaction where soaps, manufacturing of process of soaps are dealt here. As per the saponification reaction, the esters CH3, COO, C2H5 in presence of NaOH will split this to CH3 COOH plus C2H5OH. Now this is again an acetic acid, and this is alcohol. This acetic acid, this is ester. Or this is the ester. Now in the second stage, sodium hydroxide will react with CH3COOH plus NaOH. This will give CH3COONA as a salt plus H2O. This is the two-stage reaction. This two-stage reaction will give it. This is called sodium acetate, and this is water. This is the same formation what we have got it in the first stage. This is can be called as a second stage reaction. This will be called as first stage reaction.